Again, 2,000 pounds. And we want the maximum normal stress across the entire plate. Our hole's diameter, 0.75 inches. We have a thickness of 0.125 inches. The wider part of the plate is 1.875 inches. And the smaller part of the plate, 1.25 inches. And the fillet radius is 0.25 inches. All right, so where do we, in this plate, where do we have to be concerned that our maximum stress, or concerned that the maximum stress might be more than the average stress?
The hole and in the fillet.
Right, in those two discontinuities, conveniently, that we talked about, we have to be concerned that it's not enough to get P over A here and P over A here. We have to be concerned that at the edge of the fillet and really the top and bottom of the hole, that the estimate using P over A is not enough. We want to refer to the stress concentrators there to see to estimate what the maximum stresses are at those discontinuities. Right, so let's check the fillet first and find near the fillet what the maximum stress is going to be, the maximum normal stress is going to be. Again, that K value is the maximum stress over the average stress, depending on how they want us to calculate the average stress. At the fillet, this is going to be the left picture, we are to calculate the average stress using P over H times T. So it's really the cross-sectional area of the smaller of this here. So the 1.25 times the 1/8 of an inch is going to be that cross-sectional area. So for the fillet, the average stress is 2,000 over the 1.25 times 0.125. The average stress value for the fillet, 12.8 KSI. Now we want to find what the maximum is. Near the bottom of that fillet, we have to find the K value. For the fillet, we require two parameters to find the K value. We need the W over H, and we need the R over H. The W over H, W is the wider part of the object. That's going to be the 1.875. And the H value, again, is 1.25. R, for this one, is the radius of the fillet, 0.25, over the H value of 1.25. This is 1.5. That's 0.2. All right, so the R over H value is 0.2. So we're going to go to 0.2 here. But 1.5 is our W over H. That tells us which line we want to use. We want the line where W over H is 1.5. It's hard to see up here, but it's this line over here. So where that intersects the X value of 0.2 is where we want to use the value of K. All right, so when you look close up on the slide, it's going to be easier to see. But it intersects that line at around, what do I say in my notes? 1.72. So I estimated it to a second decimal place. 1.7 would probably be an okay estimate, though. So the maximum stress near the fillet, 22 KSI. At the fillet, we find 22 KSI, but we also have to be concerned about, at the hole, what the maximum stress at the top or the bottom of the hole is going to be, because it could be more than the 22 KSI. All right, so for the whole discontinuity, we're now going to this picture because this is the appropriate K chart for a center drilled hole. For here, to calculate the average stress, they want us to use P over W minus the diameter of the hole times the thickness, or that cross-sectional area, the smallest cross-sectional area through the hole is how we're going to compute that. Average stress will be 2,000. W minus 2R, that'll be 1.875. Minus 0.75. And the thickness, 0.125. The average stress for this part of the problem, for the hole, 14.2 KSI. Now for this, we want to find this K value. This only uses 2R over W. The value we get for 2R over W is going to be 0.4. There's only one line to worry about here, so we match up where does 0.4 intersect that one line. Okay, and if we look at that point, it's at approximately 2.2. So the maximum stress at the top of the hole is going to be 120% greater than that average stress. So the P over A was less than half of what the maximum stress is going to be. Using that, we can find that the maximum stress then is 2.2 times the 14.2 is 31.3 KSI. The maximum stress we found near the fillet was 22 KSI. The maximum stress at the top or the bottom of the hole, 31.3 KSI. So our final answer, the maximum stress across the entire plate, we want to take the maximum of the maximum. So our final answer will be 31.3 KSI.